Welcome to the fourth and last video of Section 6. We have so far configured Jenkins, Git, and Maven. We have also introduced the Cucumber code. Now, we are going to the real-life implementation of Selenium Web Test integrated with Cucumber. It is time to focus on the user interface and use it. Selenium integrated with Cucumber is a good and strong tool for testing the user interface. In this video, we will focus on UI test with Selenium and Cucumber in BDD style. Obviously, it will cover the acceptance test. We are using Java, and there are not too many lightweight web frameworks available. Before we implement the test automation, let's look at the flow to be used at a glance. The UI design of the page is as below. A drop-down for selecting the category. The temperature is selected automatically. A text field for entering temperature value in Fahrenheit. A text field for showing the result in Celsius. Two drop-downs at the bottom to select unit, one for Fahrenheit and the other for Celsius. After entering the Fahrenheit value in the text field, it will be converted into degrees Celsius. The window is where the result will appear. This should be pretty easy to implement, test and verify. I want to convert 98.6 degree Fahrenheit, the normal body temperature, to Celsius. The Celsius value would be 37 degree according to the equation C by 5 equals F minus 32 by 9. I have done the assertion in my code for verification. We will see that during the code analysis. But before we can do anything, we need to add Selenium support to the project. Let's add a dependency in the POM for Selenium support. This is the dependency portion of the pom.xml file. This is sufficient for us to implement the interaction with the web page. With access to Selenium, it is time to do the actual implementation. The first thing we do is to add a page object that will interact with the conversion page. Let's call it the temperature converter page. Remember that we've used the page objects to hide the complexity of interacting with the web page from our test code. There is another page object named Google. Google should take a web driver as a parameter in its constructor, and it should connect to www.google.com/ by using driver.get method. The method go to temperature conversion page will return the temperature converter page object, which is the main page for our action. That is, conversion of temperature. We should also know whether we are on the correct page. A simple way to verify that is to check the page title. If it is the wrong page, we will have to stop the execution. A simple way to halt the execution is to throw an exception. So, let's add a condition that verifies the correct page title for both page objects. If the page title is wrong, throw a wrong page exception. We should avoid using checked exceptions whenever we can. The exception we have extended here is the runtime exception. When the exception inherits from runtime exception, then we don't have to declare that it was thrown in new methods. This is pretty much what we want. If we were to end up on the wrong page, we should stop the execution. We shouldn't force our entire call stack to declare something that indicates a clear error. Let us look at the page objects, how the wrong page exception has been implemented, and the Google page. As you can see, we have implemented the wrong page exception. And on the temperature convert page, this area is where you should implement the wrong page exception. These changes should not affect the rest of the program. We can commit them. So, after changing the pom.xml wrong page exception, and after creating the page objects, let's commit the code. Go to the project repository and commit. Before committing, we need to add the missing files. type git commit -m, updated pom.xml and initiated the implementation of page objects. The files have been committed successfully. We have created the skeleton of step definitions in video 6.2. Now we have written our necessary snippet of code in conversion step defs class. There are three methods. At the rate given, a noted method, at the rate when, and at the rate then. So this portion of the code is for page transition. After moving to the correct page, input the Fahrenheit value and it will be converted to the expected Celsius value. This method is responsible for inputting a value in Fahrenheit. After it has been converted, the step that remains is its verification. For verifying the result, we have made an assertion by using assert equals. Check this line. Now, let's execute the final commit and push it to the global directory. Check the git status. Then, git add dot. Again, the status. Then, let's commit git commit -m, modify step definitions. And finally, let's push the code git push. Username and password as usual. There has been some error. Let's try again. The code has been successfully pushed. The next step is to observe the execution in Jenkins. The implementation of our small web application is done, and it's in the global repository. Now is the time to observe Jenkins. Yes, Jenkins has picked the build and it is being executed. It should pass. Whoa! It has passed! Let us visit the console output. There you go. The build was successful. That's all for this video. Phew, that was a lot. All the necessary steps have been taken for implementing the test of our web application, and it was executed well in Jenkins. Join me in the next and last section of this video course, taking a journey on advanced usage of Selenium and a look back of this course.